All right, here's another day where we're just not going to talk to each other awkwardly. But this is going to be our last day of like new-ish lesson for this unit. All right, just so you're aware, today you're going to take notes to review function types looking at a table and then comparing different functions. We're going to do one example together, and that's both sides of the worksheet you have in front of you. Friday, you're going to get a packet that looks similar to this, and you're just going to work on that with the sub, so I would really highly suggest having these notes out while you're doing that tomorrow. Monday, we're going to review functions again, what makes a function input and output. And then Tuesday, you're going to take your test over domain and range, input, output, whether it's a function or not, and then deciding what type of function it is. Okay, so one thing I've noticed we're struggling with still is recognizing how to tell what type of function something is by looking at the table. So if I look here, this function is -5, 20, -4, 17, -3, 14, -2, 11, and -1, 8. So what we want to see, the first thing you should always do when you have a table is count up the first difference. So to go from 20 to 17, I'm subtracting 3. From 17 to 14, I'm subtracting 3. 14 to 11 is subtracting 3. And 11 to 8, I'm subtracting 3. So I know that this is going to be linear because the first difference matches. Or you could simplify it and say because it's changing by a constant. So what I want you to do is I have 8 examples, A through H on the side, and I want you to go and pick out which tables are also linear. And you're going to prove that by looking at their first differences. All right, so we're going to do the same thing here. So we're going to decide what type of function this table is. So if I look, the first thing I'm going to do is I'm going to count up to see how different these are. So if I look, the difference between 1.25 and 2 is 0.75. 2 to 5, I'm adding 3. 5 to 17, I'm adding 12. And 17 to 65, I'm adding 48. So this isn't linear because I'm not adding the same thing every time. This isn't going to be absolute value because I'm not adding and subtracting the same thing every time. So I just have to tell if it's exponential or if it is quadratic. So really the only way to tell this is to take your second difference. Well, I know the difference between 3 and 0.75. I'm adding 2.25. From 3 to 12, I'm adding 9. And from 12 to 48, I'm adding 36. So because my second difference doesn't match, this has to be exponential. So my reason for this is first and second difference doesn't match. So again, I want you guys to go through. These are the same 8 tables you had on the last slide, and I want you to figure out which of these are also exponential. All right, our next function. So I'm going from 46 to 33, 33 to 22, 22 to 13, and 13 to 6. So when I look at this, here I'm subtracting 13, then I'm subtracting 11, then I'm subtracting 9, and then I am subtracting 7. So again, looking at this, the first difference doesn't match. I don't see right now that I'm changing directions. I'm not adding and subtracting the same number. So I have to check the second difference, and that's going to tell me whether it's quadratic or exponential. So from -13 to -11, I'm adding 2. From -11 to -9, I'm also adding 2. And -9 to -7, I'm adding 2. So we're going to say that this is quadratic because the second difference matches. So same deal here, A through H, which others are also quadratic. And last but not least, and I know you guys are probably using your process of elimination, you kind of already know the answers here, but I'm just going to show you what it looks like. So we need to see what type of function this is. So I'm adding 3, and then subtracting 3, subtracting 3, subtracting 3. This almost looks linear, except I changed directions right here. So this tells me it's going to be absolute value. So I'm going to say it's changing directions at a constant rate. So you need to see what other tables have that pattern to where you're adding or subtracting the exact same number each time. Okay, so now that we finished reviewing how to recognize what type of function something is through a table, we're now going to take two functions and put them onto one graph. So here's your table. So you need to take these x values and plug them into the calculator to get your y values or your outputs. So this is going to be, if you put -2 into the equation, that'll be 4, then 3, 2, 1, and then 0. So again, you get all those outputs by taking these x values and putting them in place of the x right there. From here, I want you to graph it. So everything I do in red is going to be function A. So I'm going to go to -2 up 4, and I apologize, it's really hard to graph on this. And then -1, 3, 0, 2, 2, 1, or sorry, 1, and then 1, 0, or 2, 0. Okay, so this is going to make a straight line. So function type is linear. Y-intercept is 0, 2. X-intercept, we haven't really talked about that yet, but that is where your function crosses the x-axis. So this happens at 2, 0. And my rate of change, it is decreasing at a constant. So now we're going to do the same thing, we're going to do it for function b on this side. So this again is one where you're going to get some weird numbers. So I'm going to do 2 times 1/3 to the -2nd power, and that's going to give me 18. Do the same thing to the -1 power to give me 6. And when I raise it to the 0 power, that's 2. I'm going to skip down here to the first power, that's 0.66 repeated. And then again squared will be 0.2 repeated. So for some reason this table's sort of out of order, but we just graph it like normal. So I'm going to go to -2 all the way up to 18, so that's going to be somewhere way up here. But then -1, 6, 0, 2, 1.6, so that's going to be about halfway between 0 and 1, and then 2 and 0.2, so it's going to be pretty close to 0. So this is that ramp shape. So our function type, there's an exponent of x, and it makes a ramp, so that's exponential. The y-intercept again is 0, 2. X-intercept, exponentials are tricky. This one actually doesn't have one. And the rate of change, I know it's decreasing because it's coming down, but notice that it's starting really steep and flattening out. So it's decreasing and it's slowing down. So at a decreasing rate. So make sure the back of your worksheet is filled out just like this slide. All right. So at the bottom, it says use the two functions above to answer the following questions. Which function has the lowest x-intercept? I'm technically going to say the -x plus 2 because it's the only one with an x-intercept. Which function has the lowest y-intercept? This one is none. They have the same. They're both at 0, 2. Which function is increasing the whole time? This is also going to be neither because we know they're decreasing the entire time. All right, and then you have to fill in this table. So name 2 similarities between the functions, name 2 differences. So one difference we can name about both of them is that one is linear and the other is exponential. So they're different function types. Another difference is that the linear has an x-intercept and the exponential doesn't. If you can think of other things, you can write a bunch of other things there too, but those are the first 2 that popped out at me. For naming 2 similarities, well, we already talked above. They both have a y-intercept at 0, 2. We also said that they are both decreasing. They decrease at different rates, so you could talk about that and the differences, but they are both decreasing. So tomorrow you're going to get a worksheet similar to this where you're going to graph 2 different functions and then answer some questions and compare the 2.